Okay, we will start now, and we will wait for other people to be connected with us. Then, hi everybody, I'm Majdi Sahli from Tunisia, from Tunisian Safety Professionals Association. I'm very happy to have you all with us today. Tunisian Safety Professional is a Tunisian association that is working to enhance the safety culture in the region, let's say. And today we choose to start our webinar about the hazardous area risks. I think that it's a very interesting subject for all the industries, not only oil and gas. We have a lot of people from oil and gas. Then I'm very happy to have with us our speakers. They are very busy, but they were very nice from them to give us sometimes to share with us their experience and a lot of things, I hope. Then we will start with Majdi. He will introduce the subject. I want to thank him a lot because he was the idea was from him. He pushed me to organize this webinar, and to also he make the connections with the speakers. Then he's an active member of Tunisian Safety Professional. Then I will let him the time to present himself and to start the presentation of the webinar. Welcome, everybody.
Thank you, Mahdi, and thank you for everybody. I hope that you see my screen now. I'm trying to.
Yes, it's okay.
Okay.
For me.
So thank you again.
Sorry, Majdi.
Yeah,
just before to start, I want there's a proposal from Sani. I think it's a very nice idea. It's just to start with the safety moment. Then the safety moment will be about COVID-19 and what we will say for everybody: take care of your family, don't take the risks, and respect the rules, and be safe, because I think that this crisis just shows us that the most important things is health and safety. And thanks for the idea. Sorry, Majdi, go on.
Yeah, thank you again. So thank you for all people present today with us, and thank you especially for the Tunisian Safety Professionals teams for this opportunity. I'm Majdi Belguith, sales manager in IECEx Group with more than 10 years experience on IECEx equipment sales. In IECEx Group, we collaborate with reputed partners as Ind-Ex for the engineering, inspection and training for hazardous area, and specialized manufacturers for equipment to be used in hazardous area like Erstall for electric equipment, Therman for heat tracing solution, Bourdon for gauges, BMET for cable glands, AMPCO safety tools for non-sparking tools, and Deroncourt for insulated tools. I will start with a reminder of basic definition. So explosion protection is a key area of safety engineering. So it's essential to understand the fundamental principles of an explosion and its causation factors. As per the IEC 16079, the definition for explosive atmosphere is a mixture with air under atmospheric conditions of flammable substance in the form of gas, vapors, mist, or dust, in which after ignition combustion spreads throughout the unconsumed mixture. The hazardous area is an area in which an explosive gas atmosphere is present or may be expected to be present in quantities as to require special precaution for the construction, installation, and use of apparatus. Explosive hazards exist in many industries, like chemical plants, oil and gas industries, marine and shipbuildings, refineries, cocaine plant, sawmill, grain silos, pharmaceutical and cosmetic industries, sugar or flower plants, food and beverage industry, and other hazardous area could be identified also in other industries like for located application, like paint shops, sewage treatment facilities, wastewater treatment facilities, or battery rooms. The requirements of electrical equipment for explosive atmospheres are multivarious. National and international regulations, directives, and standards must be observed and ensure maximum safety. Explosion protection is governed by directives and standards in the European Union. Started in 1976, full harmonization and extension to all types of equipment, both electrical and non-electrical, was achieved in 1994 by the new 94/9 EC directive. This was followed in 1999 by the 1999-1992 IC directive, which governs operation in hazardous area and defines safety measures for the persons working in those areas. In 2014, Directive 2014-34 EU was published, and actual implementation with regards to equipment certification took place in 2016. According to an agreement between CNELEC and the EIC, international standards for electrical equipment have generally been adopted by CNELEC as they stand. The European norm 15014 series defining requirements for equipment in explosive gas atmosphere has gradually replaced by the European norm 16079 series. The International Electrotechnical Commission is responsible for global standards in the field of electrical engineering. Scope and standards for IECEx include electrical equipment conformance to EIC 16079 and EIC 61241 series requirements. Non-electrical equipment to EIC 18079 series. Hazardous area classification according to EIC 16079 Part 10. Installation and inspection according to EIC 16079 Part 14 and Part 17. Equipment maintenance, repair, overhaul, and reclamation according to EIC 16079 Part 19. And EICEx certificate of personal competence was according to ISO 17024 and now is under validation and will be soon under the new standard EIC 16079 Part 44. National regulation may, however, differ from EIC standards. For this reason, the extent to which they may be applied in the respective countries must be verified. For example, in Tunisia, companies manage their hazardous area by the following standards and norms: EIC 16079, the IECEx directive, the IP15, which is the area classification code for petroleum installation handling flammable fluids, and the RP 505, which is the recommended practice for classification of locations for electrical installation at petroleum facilities classified Zone 0, Zone 1, and Zone 2. The National Office, OMPC, published in 2018 the safety regulation for risk of fire, explosion, and panic in buildings housing dangerous, unhealthy, or inconvenient establishment. Now, Tunisia is an EIC associate member, but what about the adoption of EICEx standards? In Tunisia, actually each company apply its own procedures and choose the standards as per the experience of its engineer.
Thanks.
Just
okay.
Yeah,
go on.
A common regulatory framework for equipment used in explosive atmosphere was published in 2011. It was important to establish a global approach for a global industry to increase the safety of workers and communities that may be exposed to such explosion. Any UN member state that does not have a regulatory framework in the explosion equipment sector may use the model as an outline for this legislation. However, the CERU can also be used by countries to align their existing national regulation with internationally harmonized best practice. The CERU are drawn up with reference to international standards and conformity assessment procedure developed by EIC and ISO, and to best practices in the assessment of conformity to such standards within IECEx. In short, use of international standards supported by IECEx certification is considered the world's best practice. I will let this part for Mike to be developed, but to define, finally, the IECEx is a conformity assessment tool providing confidence that products, services, and personnel covered by an IECEx certificate meet specified requirements. And this is 3 certificates provided by the IECEx for AX equipment, repair and services facility, and personnel certification. As conclusion, in hazardous area, the lack of competency facing the risk evaluation may lead to huge losses in terms of lives and investments. For this reason, we shall adopt the best practices and ensure their application, and it's necessary to choose the best practices from the study phase and ensure the correct application during the installation and maintenance of the equipment. Thanks again for your attention, and I give you the continuity of our webinar.
Okay, thanks, Majdi. Just to reply some questions already here, Mike already responded some of them. Just to say that this part, it was very important for us because, you know, Bertrand and Mike will speak a lot of international standard, and what we want to stress in with Majdi is that in Tunisia, unfortunately, there is no a standard, there is no regulation, and IECEx, let's say hazardous area, or what we call IECEx, is just common in the oil and gas industry because they are working with international standards and working with oil and gas companies. But for the other industry and for the, let's say, for the country, is not so detailed in the regulation. Okay, thanks, Majdi.
Yeah.
We will now just move to our experts. Let's say Mike. He will share with us his huge experience and just to introduce, let's say, the heart of our webinar. Thanks, Mike, again. I know that you are very busy, and thanks a lot to take the time to share with us. Okay, waiting for Mike. Perhaps we will start responding to some question. Majdi, there is a question for Amira Sadi. She is asking which are the IECEx directives in Tunisia.
Okay, so as I said, in Tunisia, there is no special directive or regulation. The only text is published by the OMPC, and it specifies generally the use and the mandatory, for example, said you have to use protected equipment for hazardous area, but without mention of any directive or standard to apply. So okay. By the experience of people in industries, we use IECEx directive, which are European standards. Now there is the IECEx system that Michael will introduce, which is a global approach and more specified and more precise. So Michael, now I think you can go on.
Okay, hopefully everybody can hear me right now.
Yeah,
Yeah, perfect.
Sorry about that. There we go.
it's okay.
Okay, thank you everybody for attending. When it comes to EX, hazardous areas, hazardous locations, we have global experience, but we find that the IECEx scheme is the most beneficial, the most straightforward, and the safest. With it, you can achieve efficiencies in communication, safety, quality, and therefore production. We're also introducing the concept of owner's engineering. Now, at Ind-Ex, we're hazardous area EX professionals. As we explained, we are experts in hazardous areas, quality, safety, and project efficiency. We're involved in EX industries globally. We're members of multiple standards committees, working groups, and industry groups, such as UL, U.S. National Committee for IEC, NFPA in the future, ATEX, IEC TC 31 committees, and PCIC. Some of our services include hazardous area classification, training, factory acceptance testing, and supplier quality surveillance services. So when we talk about the industries of hazardous areas, it involves, well, now that everybody is going to low carbon fuel shipping, now all those vessels, from bulk carriers to container ships, LNG carriers, hydrogen carriers. Every industry that involves hydrogen is now a hazardous area, even potentially at the home. Petrochemical, oil and gas, nuclear, as well as pharmaceuticals, foods, and all the other ones that Majdi brought up. Myself, I am a partner of Ind-Ex. I am also a member of the UL STP committee and a few others. Have the highest level of certification globally, which is IECEx CoPC, among others. Our owner, Mr. Arpad Vares, is member of 10 different standards committees, such as 60079-44, personal competence that is coming that Majdi mentioned. He also has his IECEx CoPC. Now, when we talk about hazardous areas, there are many stakeholders involved. From the beginning, there's hazardous area classification, these zone drawings. There are multiple standards that define this. 60079-10 for classification, -20 for the material characteristics. Then there are multiple for ignition hazard analysis. Next step is the manufacturers. They're defined under ISO IEC 80079-34 and multiple other standards. They make equipment that is then selected by the EPCs. At the point of the completion of a project, at handover, from the EPC to the end user, there's a verification dossier that must be handed over. This is the key linking document that must be created from the very beginning during classification all the way to the point of decommissioning. It is your tool to ensure production, quality, safety, and compliance. Now, around the world, we've noticed many projects with significant blowouts in cost, schedule, reworks. These headlines, why are they happening? Well, the reason we mention them is so that we can bring up these interests for all stakeholders as to why you should protect your interests. What are the risks and why we should mitigate them? Why are these blowouts happening and why owner's engineering is the solution? Once again, we've seen major blowouts of up to $130 billion on a project and over 10 years over schedule. So issues which can be addressed by owner's engineering are changes in scope, contract management issues, contracts poorly drafted, poor management of subcontractors, suppliers, and interfaces. And the big one is long-running skills shortages and competency gaps across all project scopes, stages, and personnel. So if we look at a typical project timeline, and you start at the beginning from the pre-feed, feed, and packages, modules, and vendors, If there are any delays, even 1 month's time, you will be looking at compounded multiple months of delays further on later on in your project. If you do it right in the beginning, things will go well. If there's any problems at the beginning, cascade effect, snowball effect, we call it. So there's problems with workmanship, companies doing things the way they've always done things, unfamiliar with strict regulations and standards, delayed packages, delayed components, differing departments, siloing going on, people not communicating. EPC phase has been identified as the most significant phase, causing an overall delay to the finishing date. But if there's delays at feed or pre-feed, EPC is going to feel the most brunt of it. So once again, vendor packages need to be ordered before construction happens on site. Any delays will then cause delays in commissioning and startup, and therefore transition to operations. That verification dossier spans this entire project. What are the solutions? Well, without radical change, this pattern of disputes will continue. Contracts should be negotiated to share and manage risks more effectively. Stage gate audits to limit scope changes and ensure designs are mature. Effective project controls. Given the growing skills deficiencies as there are downturns in the market, there's a need for owner's engineers, people to fill in gaps in competency, personnel, and other such issues. To remove siloing, remove the lack of communication between companies, within companies, or between companies. Be alert of any delays. So once again, owner's engineering, filling gaps in resources and expertise on a project. Provide all these services, cost benefit analysis, work for the owners, whether it be the EPC or the end user. Be there to review and advise designs, such as specifications, procedures, work method statements, installation standards, product selection, quality management systems, how the entire project is flowing. Give an eye on what possible issues there are and solutions. Attend all meetings. So we have defined this from the very beginning. Proper classification, design, correct equipment selection, installation, inspection, commissioning, startup, operations, and maintenance. And once again, also change management. So when is the best time to apply this? Well, it's best to apply it at the beginning, but cost and schedule benefits come in at any stage. You can increase your quality, safety, communication. You could have one subject matter expert on a project, and that one person is able to help mitigate risks across the entire project from beginning to end. So the IECEx system was created as an international trade to allow international trade in equipment and services while maintaining the required level of safety. It reduces testing and certification costs to manufacturers, reduce time to market for those manufacturers' products. It has international confidence in product assessment process, and one international database, an online database for the certification of people, facilities, and equipment. There's no need to go hunting down for certificates. So that international confidence is provided through a voluntary system, and it promotes global standardization. So IEC is there for development and maintenance of standards and conformity assessment to those standards. So with conformity assessment, it provides independent verification of claims of compliance with standards related to safety, performance, reliability, interoperability, and competence on the basis of testing and assessment of production processes, people, and management systems. No self-declaration. Majdi already went into all the possible IECEx industries. Now, when people talk about the typical fire triangle, it is not typical. On the oxidant side, most people identify as only air. That is incorrect. It is also oxygen-enriched environments, ammonium nitrate, chlorine. Fuels can be vapors, gases, liquids, dusts, fibers, filings. Now, those fibers, fibers, and flyings will be part of a hybrid mixture when you consider this fire explosion triangle. Now, ignition includes 13 different or more possible sources of ignition. Thus, expands on that, and the two other parts are confinement and dispersion. So when dust is confined within a building, those pressure waves bounce off the walls and come back with even greater force. And dispersion, when dust is in the air, it is even more dangerous and more easily ignitable. The 13 sources of ignition, they include flames and hot gases. They include hot surfaces and radiant heat, mechanically generated sparks such as, well, welding, anything that frictional heat, electrical equipment such as electrical shorts, stray currents such as from cathodic protection, static electricity. You feel static at 0.5 millijoules. Hydrogen ignites at 45 times less the amount of energy than you feel, 0.011 millijoules. You will not feel the static, but you will ignite the hydrogen. Lightning, electromagnetic fields, optical radiation, ionizing, radio frequency and ultrasonic radiation, adiabatic compression, and exothermic reactions. So it does not matter the industry. It does not matter the vessel. The physics of explosion protection remain the same. The fire explosion triangle and the dust pentagon. All these incidents, Piper Alpha, Gulf of Mexico, Montara in Australia, BP Texas City, Beirut, once again Texas City, what do they all have in common? People did not consider the safety aspects. There was always the Swiss cheese effect happening. Human-induced faults, we call it. That is the whole point of standardization, is to give solutions so that an individual does not need to come up with the solutions themselves. The product life cycle, once again, this was already went through, and we addressed it in perhaps a more simple to understand method, where we actually define the first step as hazardous area classification. Define what gases are there and the dangers of them. Now, within the IECEx scheme, there are 4 certification possibilities of equipment, marking, facilities that provide services, and persons. So IECEx is an online scheme with an online database that is free to use and simple to use. Now, conformity mark is very straightforward. It's the IECEx symbol in that right there, as you see. The services scheme, what is that? That's competence of an organization to ISO 9001 and the applicable IEC 60079 standards. So a company can be competent and not rely on an individual. Now, IECEx personal competency schemes. Competence is the application of knowledge and skills to standards of performance required in the workplace. Competency includes all the aspects of work performance and not just the skills. It's more the mentality. So we visualize it. Who must be competent? Everyone, from the constructor, the shipyard, the vendor, the user, the owner operator of the facility or vessel, and the regulators. So once again, the experience, knowledge, and skills, but the behavior, performance, and goals of those people, that's their competency. Are they willing to work safe? Within IECEx, there are 10 defined units of competency that address anywhere from mechanical people, electrical, those who attend a facility, those who do classification, design, engineering, technicians, inspectors, and repairers. There are the possibilities of doing training in person, online, with assessment, online, or in person. So on the IECEx website, there is the ability to search for equipment, facilities, and persons, and the conformity mark. It's an easy to use database. If you search for perhaps my name, you can find myself on that database. You can independently verify and validate. That is the point of the IECEx scheme. No hidden information. People can be safe when information is easy to find. Now, equipment. It's very important to read the data plate. This data plate itself, IECEx UL 08.0005U. That's a component certificate. How do I know this? I went to the IECEx website and downloaded the certificate. Now, IEC brings this all together, bringing that equipment certificate shall be prepared for each installation, but it shall be part of a verification dossier. A verification dossier is like an equipment register. Each individual item will be a row. You could have 300,000 items across site, and each column is a different data set. So this can be kept digitally, which I highly suggest, or a hard copy. It's done in order to correctly install and maintain and ensure the safety of an installation. What is first done is area classification, defining what gases, vapors, liquids will be there, dusts, what their ignition temperatures are, their material characteristics, any possible external influences such as ambient temperature, any other possibilities that could cause ignition. We then define what those gases are and its relative density, lower flammable limit, gas group, and temperature class. We do this in a very organized method. Then we define the sources of release. Where is that gas coming from? Which flanges? Which valves? Which locations on the facility? We take a plot plan and overlay a drawing as to where those hazardous areas are. We give visual indications so that then the designers can source the correct equipment and the procurement can order the safe equipment that will be safe for the hazardous areas that have been defined. Now, the next step of part IEC documentation is the manufacturer's, well, the equipment and the manufacturer's instructions, documentation such as the certificate, any relevant calculations, and manufacturer's qualified persons declarations. So what does that look like? Well, for intrinsically safe, we need to verify those intrinsically safe circuits, and it calls for a descriptive system document, which is called for in that note down there to IEC 60079-25. So in that standard, it will talk about systems. When you think of intrinsically safe to -11, that's just one of the pieces of equipment. Intrinsically safe is from the barrier, the cables, junction boxes, the equipment at the end, and any other equipment that is part of that loop. So that descriptive system document describes all the requirements, and the IEC standards give you the calculator and the format and layout for the possibility to define your hazardous areas, such as in this format. Gives you layout, gives you cable schedule, terminations, makes it very easy. And once again, you have your individual IECEx certificates for the individual pieces of equipment. Another requirement is installation information. So first we start with classification, then we had the equipment details for when it was being designed and ordered. Well, then you need all the other documents, such as the layout drawing, the certificate and the data sheets, ensuring that the correct model is installed in the field. With that, you will have wiring termination drawings. You will have single line drawings. You will have general arrangement drawings, even piping and piping and instrument diagrams, perhaps heat tracing isometrics, hookup drawings, loop drawings, and the individual person's certification who will be doing the initial inspection. Now, what is the format for perhaps inspection tables? Well, IEC gives that format, and we have defined it perhaps in an easier format, which allows comments. Now, what does a verification dossier look like? Gentlemen, it's literally a spreadsheet. It can be implemented into SAP, Maximo, any of your CMS, any of your document management systems. It's very easy to integrate. First thing you do is, well, you have all your number of your equipment individually tagged, a unique tag. You then define what the description is and where it is installed, when the inspection happened, to what grade of inspection, detailed, close, or visual. You have the equipment details from the manufacturer, model number, and serial number. You then have all the EX details, protection, gas group, temperature class, ambient temperature range, IP rating. You would then have the hazardous area classification, what it is rated for, and you do a gap analysis between the equipment and the classification. You make sure the equipment is safe for the area. You then have the details of the certification, the IECEx certificate. You make sure the equipment is not fraudulent, that it has not been pulled from the market due to safety reasons. So all this and conditions of use, very important. They tell you how to use that equipment without causing ignitions, any explosions. All that information is stored, whether it be text or links to other parts of your database. They're all located in that verification dossier or equipment register. Now, when we talk about potential sources of ignition, there's 13 different ones. Lightning strike hitting your facility, hot surface, spontaneous heating, electrostatic discharge, lightning, and magnetic radiation. Now, when we talk about hazardous area classification, once again, it's a plot plan. You define the characteristics, the source of release, you identify the environmental data, and you plot it out. It's a risk assessment. It comes down to a basic risk assessment. Now, major issues that we find within industry: water in everything, poor ingress protection, failure of components, dissimilar metals, selecting incorrect products. Once again, lacking of, well, something as easy as a breather drain could stop water from getting into your lights. You can extend your product's life cycle. Poor preservation practices, water getting into high voltage joints, poor selection or use of North American wire nuts, and poor selection of terminals, and not using ferrules, using pin crimps. Easy solution: choose the correct item, use high quality terminations, will solve many issues. Now, when we talk about the differences between ATEX and IECEx, well, ATEX allows for manufacturer self-declaration, while self-certification is not allowed by IECEx. The use of manufacturer's data or unwitnessed test results is not permitted. So what are we saying? IECEx is much safer than ATEX. Why do we know this? Well, we actually have a museum of equipment, ATEX and IECEx. This is our passion. So from this, we hope that you have an idea what owner's engineering is, and that it is a potential solution for any of those who may think that IECEx is difficult to understand. We're there to help people understand. Thank you very much.
Thanks, Mike. It was so interesting. There is a lot of questions for you. I will let you the time to read. What I want to say again, that when we fail to secure our installation, our plants, what happened is explosion, and explosion is about lives, about people. That's what happened 2 months ago here in Tunisia, in Gabes. 6 people died, 6 families. There is not a joke. Then sometimes it seems complicated, perhaps. I know that in Tunisia the culture is not here, but I think that we need to bring this culture. We need to push to have expertise, to start identifying our area, our risks, and after that to put in place the necessary equipment with specialists. It's not about just to go to the next shop and say, okay, I have a problem with explosion, I need this equipment, and this equipment is not so easy. And sometimes we make the let's say the survey, the risk analysis, we identify our zones, but we don't choose the right equipments. And when we say, people think that it's only equipment, but there is also tools. And now I think that Mr. Bertrand will introduce more this subject. Thanks again, Bertrand, for your time, and you can start your part and introduce yourself. Welcome.
Okay, thank you, Majdi, for giving me this opportunity. It's the hand tools are not let's say very, very essential in the organization of the companies, but they become more and more essential, and it's a great opportunity for me to talk a little bit more about our products, let's say that it's compared to the general information that Mike just gave. We are going to highlight probably one of the causes of potential explosions in the ATEX zones. I'm just to introduce myself and the company. AMPCO Safety Tool is the oldest company in the field. AMPCO Safety Tools has been created in 1922, so we almost 100 years old next year, and we're very proud of this, and we have accompanied all the people looking for safety during all that time. And as far as I know, there was no let's say explosion or injuries caused by an AMPCO tool. So it's a great achievement, and of course we try to maintain that very high level of safety for the people. What I'd like to highlight here is that we are more with the tools in the maintenance. Our customers, the end users, are people working in maintenance in the ATEX zones mainly. Of course, ATEX zones can be various, as everybody described, and but of course mainly in the oil and gas, let's say refineries and petrochemical industries, which is the big part of course the ATEX zones and the field where the tools are used. when talking to end users and or HSC people, some question arise, and of course there are some questions about you know, the use of the safety tools, about the materials, the quality, etc., etc. But the main question is, and very often people are asking for certification. That's a big point that I'd like to highlight here. And in the presentation that is going to follow, I'd like to give some useful information how to satisfy the safety of the people. I just wrote down what Mike said earlier, and I think it's a very important point for me. And he says about the people, are you willing to work safe? And that, to me, that's a very important point. Are you willing to work safe? If the answer is yes, then you should also make a big point on the tools, hand tools that you are using. So let me jump into the presentation. And yeah, non-sparking tools for IECEx environment. Unless to say that one of the most important thing is that there is no directive for making a hand tool. The tools are they don't have their own source of ignition, so they don't fall into a specific IECEx directive. So the X sign cannot be used because hand tools are not classified as equipment. But you know, the final responsibility, and I think it also come back to what Mike just said. It's the responsibility remains with the employer for the safety of the worker, and using safety tools is one of the key points to avoid the risk of explosion. So even though there is no real directive to or certification for the tools, you should be sure that your tool is safe. And when we talk about safety in hand tools, what you need to look at is, of course, the non-sparking properties. That is the main point. If you want to work safely, you need a non-sparking tool, of course. And another point is for the safety of the people, you need a reliable and a safe tool when you use it. So regarding the non-sparking properties, hand tools, of course, should be made from non-sparking materials, and that's a very important point, of course. So what you need to do is to make sure that the tools are really non-sparking. There are many materials that are non-sparking, but most of them are too soft to make tools. So, but the one we use to make our tools have been tested by a third laboratory, which certifies that the materials used to manufacture the tools are non-sparking. That's a point. And to be sure that the tools you're purchasing or buying or using, you need to know if the production has been done with these materials that have been tested by a third party laboratory. So the two documents that you need is, yes, the tools have been made from non-sparking materials, and AMPCO is providing a tool that is made from these materials that have been tested. So that's the way we guarantee that people can work safely. The second point is having a tool safe during usage. And of course, a hand tool needs to be strong and reliable in order to avoid injuries from breaking, not only the non-sparking properties. And people need to choose the right material and make sure they're built in the state of art. As I said, you can make a tool with many different materials, but they need to be strong and be made with the state of the art in order to be strong enough and not to injure the people also during use. People forgot that there are many areas where you can use non-sparking tools, and there are many solutions for safety when you use when you come to tools. It's true that most of the people, they think about, let's say, the striking tools, hammers, striking wrench, but there are many IECEx zone in many different fields, and safety tools can be very various. We have 6,000 SKU. And as you can see, you can have also picks or shovels and also screwdrivers to maintain some electric equipment in the IECEx zones, of course, when the electricity is shut off. But I just want to highlight that it's the safety tools are not only just striking tools and to dismantle valves or flanges, but they are more and more used in the different fields and different areas, of course. Safety of the workers is of course our common priority, and AMPCO safety tool motto is protecting lives since 1922. So really we are a little part of the safety of the people, but you know, I guess that there is no small or big part. As Mike described, every single little thing is important to be sure that we can work safely in these dangerous zones. So that's it. I'd be very pleased to answer any question that may arise, of course. So
if you can come back, Bertrand, for the slides with the tools, the picture of the tools, please.
Okay.
Perhaps just to have the time to see the type of the tools. I think that what we want to outline with the part of Bertrand, that is not only equipment, but also tools that are very important to choose the tools to use in a classified area, because there is the risk to start ignition with using the bed tool. That's the part that we want to share with you. Thanks, Bertrand. Thank you for your time. We'll start questions. Let's say for me, the most important part of the webinar is to share with our attendees questions, and I think that Mike take the time to text all the questions. Okay, I have one for you, Mike. You know, when I was working for Nawar project, the first safety study we did is hazardous explosion and risk analysis, and I want to explain perhaps, or to understand also, what is the difference between FIRA, fire and explosion risk analysis, and hazardous area classifications. Just what's the common part and what's the difference? The Mike, your micro, you need to turn it on, please.
So fire and explosion risks are usually done during HAZOP, so hazard operability studies, and that can take into account, let's say, BLEVI events. That team should have a hazardous area classification expert involved during that process. Now, knowing what gases, vapors, and liquids are very important for the hazardous area classification team. So as part of the hazardous area classification team, you should also include HAZOP experts, because you will have chemical engineers, process, instrumentation, electrical, even meteorologists, because you need to know what the ambient temperature conditions are. Now, why is this important? Because every facility is run by the process control systems, PCS, safety instrument systems, and fire and gas detection systems. So these are your layers. You have your process safety, which then goes into your alarms and shutdown. And then there's the emergency shutdown. Then you get into your passive and active layers of protection. And then you lose control and you send in the firefighters. We try to control everything with instrumentation. If your gas detector is operating functionally correct, that is wonderful. And if it's SIL rated, but if it's not hazardous area rated, you could detect gas, then cause an explosion of that gas. So your safety instrument systems and your process control systems and fire and gas detection all need to be hazardous area rated, because these are the layers of protection that were identified during the HAZOP and during the hazard identification study. So these teams need to work together. If they do not, well, we have seen vessels where UPS systems have been removed. So all of the fire and gas detection and SIS systems, if there is an explosion or power is lost, operations of these safety systems will cease to exist. So we impact each other. We need to work together, and that is how a facility safety is maintained, SIS, and personnel safety is maintained, fire and gas detection systems, and also safe design of the facility. So
okay,
therefore,
thanks.
correct selection of equipment to make sure everything operates safely.
Okay, thank you. Thank you. A question for you, Bertrand, from Dean Bayman. Is there any standard on no sparking tools? The micro on, just Bertrand, please.
Sorry, that's what I tried to explain at the beginning of the presentation. There is no standard or let's say certification per se on the hand tools. What we highlight with our certificates is that the tools are made from non-sparking materials. IECEx does not defines what the tools needs to be made of, or how they need to be made of, and they don't classify the hand tools as IECEx. So there is not really a standard, and we cannot classify our tools with the sign of epsilon X, because they don't fall into the IECEx directive per se, but they help to fulfill the recommendation of the IECEx, which is more the organizational way of following this directive. People need to secure themselves with the maximum things they can, and one of those is to use non-sparking tools in order to avoid an explosion.
Thank you, Bertrand. Just a question to Majdi now. You are working in Tunisian, let's say, an industry, and you know what is going on. How you judge, let's say, the awareness of industry in Tunisia about the risks of explosions, and how companies or which type of companies that are working on and they are really taking this as serious, and what's happening in the other industries.
Okay, thank you. In Tunisia, let's say it will depend on the owners of the facility. If it is a multinational company, which is obliged by the insurance and their headquarters to apply some standards, so we will find a very, let's say, a good application of the standards on the and the procedures, and it's very well explained and applied. But what might explain the process of the is from the design until the installation, and there is a lot of intervenant in this cycle. There is the EPCs, there is the people who will make installations, people who will make the design, selection, the sales of equipment, people who will be inspect and validate installation. So all these people don't have in our countries. It's not applicable only in Tunisia, but for the I can say for all the world, it's not the same level of application. This is due that before with the IECEx directive, it wasn't very well clarified, but this is changed with the apparition of IECEx, and now people who are applying the IECEx standards have all clear for them. That's why it's the best practice. The situation for Tunisia, we are not until now aware of this system. Maybe we are aware that there is certification from IECEx for equipment, but not all people, for example, are aware that there is a certificate of personal competence. A lot of people also for maintenance are not aware that an equipment X should not be repaired in the maintenance shop without being certified to do this. So the IECEx system scheme provide a solution. We can certify the maintenance shop locally.
Okay, thank you, Majdi. Just to why we organize this webinar, because of that, because we are not aware of this hazard, we are not working on it, and really it's very dangerous. Everybody, and the mic shows it. The explosion in Lebanon port is something very dangerous. People that, when we are not aware of the hazard, is very dangerous. Then we need to work. I hope that people that not start working on this part of risks start now to work on it, and just not making the analysis with our methods, probability and consequence. No. The hazardous area classification, we need to go to and to ask for professionals, for people certified. And I see a lot of people asking how we can be certified. Okay, there is a lot of things. Mike, thanks. You respond very well for this question. It's not about just to have a paper sheet that, okay, I am IECEx. I make IECEx training. I make hazardous area classification training. We need to practice. We need that's why I also ask people before starting any study with the name. Don't care about the name of the company that will make the study. Care about the person who will do that. he needs to be professional, he needs to have experience in the same area of the industry, and you can check with the database. I think Mike showed very well how you can check this in the database, and be sure that you have the good information, and after that buy the right equipment, check your tools, and also make your maintenance, because it's just about one shot. I make my hazardous area classification, and after I forget for that for 5 years, 10 years, and I will come back. Mike, how many times we need to make our hazardous area classifications? Let's say, I know you speak about management of change. Any change you need to come back, but sometimes we don't have the let's say the money for that, and even we say that if we don't, we will it can cost the accident cost more. But sometimes we are speaking about economic people from business. They just speak about money. They don't see the impact after.
What we actually have is we have a hazardous area classification tool called R-Gas and R-Dust. What it actually allows for is for you to verify and validate your hazardous area classifications. Every single time you make a process change, add a new vendor package, change routing of piping, you're supposed to revise your hazardous area classification. If it's not a fully welded pipe, it's a source of release. For example, as everybody's going into the hydrogen industry, this is the second most dangerous gas there is. Yet many electrolyzer companies like to tell us, no, the hydrogen just goes away into the air. There are some good manufacturers of electrolyzers, and there are many who do not know the risk. Why? They started up after 2014, and they're chasing the green dollars, subsidies from governments that have been promised to them. They do not read the standards, perhaps. Perhaps they are PhDs without on-site experience. So what can be done for classification? Raise awareness, maybe scare them a little bit, then maybe things will change. We could show you many hydrogen explosions, but what can be done? Become certified yourself within the company and use a calculator such as R-Gas, where we can teach you how to use it, and you can actually see the variables in, the variables out, and you can be that feedback, QA, QC feedback. Therefore, you take the responsibility, but now you have a tool that makes it easy to understand for you to do it.
Okay, I think that we come to the end of this webinar. I want to thank a lot our speakers. It was such a pleasure to know you and to share this experience with you. I hope that just we give some idea. We cannot go in details for everything. You have the contact details of Mike, of Bertrand, and Majdi, and you can ask them. I think they will be very happy to receive your question or anything. A record of this session will be shared in our page. It will be sent to all people registered in this webinar. We get about 700 people registered in the LinkedIn. I think that it shows that people are aware of this, the importance of this this topic. Also, I want to thank our let's say other association they help us to have the webinar jam. They share with us their tool. PMI Tunisia chapter, they are supporting us, and I want to thank them, especially Mr. Mabrouk, the president of the PMI Tunisia chapter. See you in our next webinars. Thanks again. I will let our speakers to say also goodbye. Thank you and see you.
Thank you very much, Majdi, again for organizing this thing. Truly appreciate. And of course, if people want to know more, they can contact me, and I'll be pleased to answer. Thank you, and thank you, Majdi, also your support, and I truly appreciate also.
Welcome.
Thank you very much,
Michael.
gentlemen. Do appreciate it.
Thanks a lot.
Thank-
Bye-bye.
Thank you. Bye.
Thank you, Majdi, again. For sure, we will have other session and other webinars together. Thank you.
Okay.
I hope so. Bye-bye.
Bye. Bye. Bye.
Bye-bye.
Thank you.